Okay, we are going to do lesson 9.6 and 9.7. This is the end of chapter 9 on the system of equations. So the wind and water current problems. Let's imagine you can paddle in still water at 3 miles per hour. There's a trip that takes you 12 miles upstream and 12 miles back downstream. The current is 1 mile an hour. So if you go with the current, that would add to your speed. What would your speed be if you went with the current? It would be 1 plus 3, so your speed would be 4 miles an hour. If you go against the current, it's going to be harder. You're going to go slower. And so you would subtract the current that you would be going against. So 3 minus 1 would be 2. If you make a full round trip, is your timing the same in the current as if you were to make it in still water? So with no current, your rate is 3 miles an hour going upstream and downstream. If you're going 12 total, then you can work this backwards. 12 miles divided by 3 miles per hour is going to leave you the number of hours that it takes. So 4 hours for both downstream and upstream. What about if there was this 1 mile per hour current? So your rate downstream going with the current is going to be 4. And going against the current, your speed is going to be 2. So going upstream, your speed is going to be 2. The distance of the trip stays the same. Both times it is 12 miles. So your timing is going to have to be your distance divided by rate to get time, because our equation is that rate times time equals distance. So 12 divided by 4 is going to be 3 hours, and 12 divided by 2 is going to be 6 hours. So if we make the full round trip, is our timing the same? Well, our timing without current was 8 hours total. And with the current, we went faster when we went downstream, but slower going upstream. This time is actually 9 hours total. So going in current is going to take you longer overall. Even though you go faster downstream, you're going to go slower upstream. So this principle of adding or subtracting the current is the same as wind currents as well. So in airplanes, you can add or subtract the wind. Let's look at our second example. A jet can travel the 6,800 kilometer distance between New York and Paris in 6 hours and 48 minutes with the wind. The return trip against the wind takes 8 hours. What is the rate of the jet in still air and the rate of the wind? So I like to make tables for these, and I start with rate times time equals distance. And our different rows are going to be with and without the wind. So with the wind, meaning it goes faster, and then against the wind, meaning it goes slower. The distance of the trip is the same. New York to Paris is going to be 6,800 kilometers, whether you're going from New York to Paris or Paris to New York. Remember, that's how we talked about the commutative property. Whether you're going to work or from work, your commute distance is the same. That was just a little side note. All right, so we are going 6,800 kilometers. When we go with the wind, it's 6 hours and 48 minutes. So with the wind, 6 hours and 48 minutes. Now we can turn that into a decimal or a fraction in just a minute. And the return trip against the wind, so against the wind, is an 8 hours exactly. What is the rate of the jet in still air and the rate of the wind? So let's label a few things. We're going to call it the rate of the jet is going to be J and the rate of the wind is going to be W. So with the wind means that they're going to be going faster, right? The wind is going to help you. So that would be the rate of the jet plus the rate of the wind. Against the wind is going to make you go slower. So that would be the jet minus the wind, because if you're subtracting the wind rate, then that's going to be an overall slower rate that you are traveling. So I said that we were going to turn this 6 hours and 48 minutes into either a decimal or a fraction. How do we do that? Well, 48 minutes is what part of an hour? So we're going to talk about minutes over minutes. 48 minutes over 60 minutes would give us the fraction of the hour it is. So you could reduce this, it's factors of 12, so it's 4/5, or you could divide it in your calculator and figure out that it is 0.8. If we add that to the 6, then we can say this time right here is 6.8 hours. Now we have some equations that we can set up. We can set up this first row and this second row. So the rate times the time equals the distance. And then the second one, the rate times the time equals the distance. You could distribute your 6.8 and your 8 through the J and the W. We do have two equations here and we have two variables, so we're trying to solve them. So you could distribute first and then maybe do substitution. Or a really nice way to do these would be do some work before and then use elimination method. So what I say the work before, if I divide this by 6.8 and I divide this part by 6.8, then I'm going to get J plus W equals an even number here because you're dividing. So it's 1,000 exactly. You're dividing 68 by 6.8 or 6,800 by 6.8. And then over here, we're going to divide by this 8 so that I just have J minus W. So J minus W equals 6,800 divided by 8, which is going to be 850. Now I have two very simple equations that I can set up as elimination. J plus W equals 1,000 and J minus W equals 850. And I can add these equations together and that W will be eliminated. I'll have 2J is equal to 1,850. Now I'm going to divide by 2 and I'll get that J is 925. So what does that make W? Well, I can use either one of these. If I do 925 minus something is 850. Or I could jump over here and say 925 plus what plus W equals 1,000. So I can easily see that 925 plus W equals 1,000, that I need to add 75 to 925 to get 1,000. So the wind is 75. Now we go back and look, we had kilometers and hours, so that would be in kilometers per hour, and 925 would be in kilometers per hour. So the rate of the jet and still air is 925 kilometers per hour. The rate of the wind is 75 kilometers per hour. This one, match each equation with its corresponding statement. So pause the video and see if you can do this one on your own, and then I'll go over the answers. Okay, A says a rowboat traveled 20 kilometers upstream and 30 kilometers downstream in 2 hours. Or B might be a little easier to start with. A rowboat traveled 30 kilometers upstream in 2 hours. So what is upstream? That's going to be the rate of the rowboat minus the current. Because upstream is going to be harder. It's going to take us more time. It's going to make us go slower. So our rate will be slower overall. So the rate of the rowboat in still water minus the current would be the upstream. Now, our entire equations are always rate times time equals distance. Now, these aren't quite set up that way, but we can figure it out. So this is our rate. Our time would be 2 hours. And we want to know, we know that it's 30 kilometers is our distance. So again, none of them look like that. However, I see that the R's and the C's are always in the denominator. So I'm going to try dividing by the R minus C. So if I divide by R minus C on both sides, I'm going to have that 2 equals 30 over R minus C. And that is one of our equations. So that one matches right there. What about a rowboat traveling downstream? That means it's going to go faster. So our overall rate, we want to add the current to it. It went in 2 hours and it went 30 kilometers. Again, we're going to divide by the R plus C. So we'll have that 2 equals 30 over R plus C. So that's going to be this one up here. All right, a rowboat traveled 20 kilometers upstream and 30 kilometers downstream in 2 hours. So we know from these two simpler ones, if they're traveling upstream in 2 hours, it would look like the distance divided by R minus C. We have to add two things together in this top one. So let's see if we can write it as a fraction plus a fraction equals the 2 hours. Okay, upstream is going to be R minus C, and they went 20 kilometers. So 20 kilometers upstream, R minus C. Now we want to add the downstream. Downstream is going to be 30 kilometers, and that rate will be R plus C, because downstream we get to go faster. All of that was 2 hours. This rowboat was really, really going fast. So this one, with a little bit of rearranging, looks like number 4. Process of elimination is going to tell us that 3 is D, but let's check it out. A rowboat traveled 30 kilometers downstream and 20 kilometers upstream in the same amount of time. So same amount of time means we want them equal to each other. 30 kilometers downstream is going to be the R plus C. 20 kilometers upstream will be the R minus C. Oh, it looks like there should have been some 20s in here. But it would be this one that is equal. So it looks like this needs to be 20. And this one should have been 20. Or we should have changed these parts. Okay, let's look at 9.7. All right, so these are puzzle problems. There's a couple about digits. So let's talk about a digit problem. A digit problem is based on our decimal system of numeration. So a value of 537,604. Oh, two different numbers, sorry. We're showing 537 and we're showing 604. How are they shown with the digits like this? So you have 5 times 100 makes the 500. 3 times 10 makes the 3, and 7 times 1 makes the units. So if we didn't know what the number was, but we were just talking about the digits, we could label the H as the hundreds digit, the T as the tens digit, and maybe U as the units or the ones. And then if you want to make the number, you would be multiplying the digit that's in the hundreds place by 100, and the digits that's in the tens place by 10. And then the unit just has to be multiplied by 1. You could even leave that off. So that's how you're going to work these digit problems. When it talks about the number, you want to make sure you're multiplying it by the place value that it is. If it's just talking about the digits, like the sum of the digits, then you can just use the variables. So the sum of the digits in a two-digit number is 12. Okay, thank goodness it's only a two-digit number. We have tens and we have units. So we're going to add the tens digit to the units digit, and that is going to be 12. So that's what our first sentence says. The new number obtained when the digits are reversed is 36 more than the original number. So the original number plus 36 is the new number. Now, this is not our equation. This is just kind of me taking that sentence and writing it out. The original number is going to be 10t plus u. Because remember, the t is the tens digit, and if we want the whole number, we need to multiply the tens digit by the place value it's in, which is 10, and then we can add the unit digit. So that's the original number. We need to add 36 to that number to make the new one. So how are we going to talk about the new number? We're going to switch the digits. So instead of the tens and the units, we're going to have the units digit and then the tens. But so that means that units digit needs to be multiplied by 10. And the tens digit is just the units value. So that's the confusing part here, is just, if you're switching the digits, then you need to multiply them by the place value that they're now in, which is a new one than what they were originally. So that's our two equations. T plus u equals 12, pretty straightforward. This one looks a little bit more complicated, but I think we could use substitution. So you can substitute, you can go either direction on this one. I'm going to subtract the t. So I have that my u is equal to 12 minus t. Now I'm going to plug that in up here on my u here and my u here. So I start with the 10t plus u. U is 12 minus t plus 36 is equal to 10 times u, 12 minus t plus t. I'm going to distribute the 10 right here. 120 minus 10t plus t is equal to, I could add some of these together while I work this. 10t minus t will be a 9t. 12 plus 36 is going to give me 48. I might want to add these together too. Minus 10 and a plus 1 is going to be a minus 9t. So I'm going to add a 9t to this side. I'm going to add 9t to this side. And when I do that, that's 0. So then I will subtract a 48 on both sides. And I have that 18t is equal to 120 minus 48, 72. And now I want to take 72 and divide it by 18. I will get that t is equal to 4. So t is equal to 4. I'm going to plug that back in up here. 12 minus 4 is 8. So that's what u is equal to. So t is my tens digit and u is my units digit. So my number, my original number, was 48. 4 for the tens and 8 for the units. So let's see if that works out. The new number obtained when the digits are reversed. So my old number was 48. The new number obtained is 84, is 36 more than the original. So is 36 plus 48 equal to 84? It is. And then the sum of the digits, 4 plus 8, does equal 12. So we are correct. Remember, with all these problems, we can check our answers, make sure that we did it correctly. Okay, with the numerator and denominator, usually we're just going to put them into a fraction. We don't need to multiply by a place value in these cases. So the numerator of a fraction, I'm just going to use n for numerator, is 3 less than the denominator. Remember, 3 less than means we're going to subtract 3 from the number or the denominator. If the numerator and denominator are each increased by 1, the value of the resulting fraction is 3/4. So our original fraction is numerator over denominator. If they're each increased by 1, so if we have n plus 1 over d plus 1, that's equal to 3/4. So these are our two equations. To utilize this one with the fractions, I'm going to go ahead and just cross multiply to make it, or I'll show you how to do it without cross multiplying. So I want to get rid of this fraction. I'm going to multiply by 4 on both sides. When I multiply this by 4, I'm really just multiplying the numerator by 4. If I want to get rid of this fraction, I'm going to multiply by d plus 1. And so this cancels right here, and I'm going to multiply this side by d plus 1, and that really just goes into the numerator. This d plus 1 cancels with this one, so I have 4n plus 1 is equal to 3 times d plus 1. All right, so now I have an equation without fractions. Again, what I just did, multiplying something to get rid of the divisor, you could talk about with cross multiplying. So n plus 1 times 4 and 3 times d plus 1, that's exactly what it came out to be. I'm going to go ahead and substitute this d minus 3 for the n right here. So 4 times d minus 3 plus 1 is equal to 3 times d plus 1. I can combine this in here and it'll be d minus 2. Now I want to distribute. 4d minus 8 is equal to 3d plus 3. I always like to try to go to the positive side if I can, so I'm going to subtract the 3d. And I'm going to add the 8. So 4d minus 3d is just 1d. 3 plus 8 is 11. And the numerator is the denominator minus 3. So the numerator is 11 minus 3, which is 8. So my original fraction, put the numerator on top, the denominator on the bottom, it's 8 over 11. So does that second sentence make sense? If the numerator and denominator are each increased by 1. So if the original fraction is 8 over 11, if I increase both by 1, I would get 9 over 12. Can I reduce that to 3 over 4? Yes, if I divide both the top and the bottom by 3, 9 divided by 3 is 3, 12 divided by 3 is 4. So that does reduce to 3/4. And the numerator is 3 less than 11. That's correct. All right, the other type of problem in this section is some age problems. So let's look at that. Cece is 24 years younger than Joe. I'm going to take just that sentence. I'm going to use C for Cece. I'm going to use J for Joe's age. So C is for Cece's age. Cece is 24 years younger than Joe. So Joe is older, and we subtract 24. 6 years ago, she was half as old as he was. How old are they now? What does 6 years ago look like? Well, C is Cece's age now. 6 years ago would be C minus 6. And so that was 6 years ago. And what was Joe 6 years ago? Well, he was J minus 6 years ago. She was half as old as he was. So she was 1/2 of Joe's age. And it was Joe's age 6 years ago. So how old is each now? We just need to solve for C or J. I'm going to use substitution. I'm going to put this in right here. So I have J minus 24 minus 6 is equal to 1/2. I'll go ahead and distribute while I'm here. 1/2 J, and then 1/2 times 6 is going to be 3. At this point, if you don't like the 1/2, you could multiply everything by 2. I'm going to go ahead and keep it because 1/2's not too hard for me. Negative 24 and negative 6 is going to be a negative 30. So I'm going to add 30 to both sides. That makes it 0. And then I'm going to subtract this 1/2 j. If I have 1j minus half a j, I have half a j left. And then because this was minus 30, I added 30, so that's 0 on this side. This one is now 0, and minus 3 plus 30 is a positive 27. If half of j is 27, what's a whole j? Well, we can multiply by 2 to get rid of that half. So an entire j is 27 times 2, or 54. If CC is Joe's age minus 24, we can take 54 and subtract 24 and get that CC is 30. So you would want to write it out. CC is 30. Joe is 54. All right, so those are all the types of problems that could be in there. You're using variables for digits. If you need the real number, then you need to multiply the digit by the place value. If you're doing fractions, I don't think any of them will go too hard. If you need to flip the fraction, if it says something about if we reverse the digits of the fraction, or if we flip the fraction, you just write it like this, d over n, instead of n over d. And then the age problems, if they talk about certain time years ago, then you want to take the current age that you're using for your variable and just subtract things.